Mario Buildreps, and Crustal Displacement. You are listening to Brothers of the Serpent podcast.
And welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents. This is Brothers of the Serpent podcast, and we are coming to you not live from the 10 by 10 by 10 Tangent Cube of Science, where we are nestled amongst the dusty bones of an ancient seabed high atop the Edwards Plateau. I think we got a great show for you guys this week. This is the one we attempted to do last week that didn't work. So we did it this week. It's much better. And so we do have Marty Garza joining us on this episode, and he's going to be with us for the whole thing. So thanks,
How's
Marty.
everybody doing?
Yeah. No UFOs this time.
No. Yeah, a little different topic.
Yeah. Marty was the what would you call that? He was the slideshow operator guy.
Yeah.
Next slide, please.
He's also the reason why we are doing this in the first place.
That's right.
So.
He did set this interview up. So
we appreciate that.
yeah. Yeah. So let's tackle space weather news real quick here. From spaceweather.com. A geomagnetic storm is brewing. Earth's polar magnetic field is unsettled on August 7th in response to the arrival of an unexpected solar wind stream. The planetary K index has reached 4, which is almost a geomagnetic storm, and could soon hit 5, which is a minor geomagnetic storm if this buffering continues. Also, a solar filament snaps but misses Earth. A magnetic filament in the sun's southern hemisphere snapped during the early hours of August 6th, hurling pieces of itself into space. The NASA's Solar Dynamics Observatory recorded it. The debris will not hit Earth, but meanwhile, there are 3 more filaments arrayed across the sun's southern hemisphere, and 2 of them are almost directly facing our planet. So maybe when one of those bursts, we might get hit by those. Current conditions, solar wind speed, 544.0 kilometers per second. The density is 10.83 protons per cubic centimeter. Sunspot number is 69. Neutron count is 3.1% above the space age average. K index, like they said, is 4, which is at unsettled, and the 24-hour max is also 4.
So how long does it take for the particles to actually run into us?
Couple of days.
Yeah.
Yeah. 2 or 3 days, usually. All right, crypto update. Bitcoin, $23,178.84. Ethereum is $1,708.61. All right, there are your quick updates for the week.
Thank you.
Yep. So, what do you think? Should we just dive right into the interview?
Yeah.
You got anything you want to say beforehand?
I don't really have any updates, I don't think.
Okay. All right, well, here we go. This is our interview with Maarten from MarioBuildreps.com. And we are back, ladies and gentlemen. This is Brothers of the Serpent podcast. And first, I want to introduce, we got 2 guests today. First, I want to introduce a returning guest, Marty Garza. Thanks for joining us, Marty.
How are you doing, guys?
Doing great. So you're here to help us out with this. We've been planning this for months. Planning it for months.
Yeah, I've been talking about this concept for at least 2 years now.
Yeah.
I figured it was time to get Mario on the show and have him explain it to us.
Yeah, get it from the source. So we are also joined by Maarten. He is from the Mario Buildreps website. That is his website, and he has a whole bunch of research about ancient sites and pole shifts, all kinds of the topics we love to discuss here on Brothers of the Serpent. So welcome, Maarten. Thank you for coming on the show.
Hi guys. Thank you for having me.
So we actually, just full disclosure, we tried this once. It didn't work out last week. So this is attempt number 2.
Take 2.
Take 2, yeah. So tell us again, Maarten, what is your background and how did you get into this, and where are we going today?
My background is technical. I'm a graduated engineer from profession. I'm still working as an engineer. And the last 7-8 years, I have I stopped working totally, and I worked absolutely 100%, 7 days a week on this ancient structures. Let's say the orientation of ancient structures and what this means. And I discovered some incredible things, and we can talk and discuss about it. And so my background is not in geology or archaeology. It's really technical and mainly mathematical, and that's my specialty. So, and sometimes people ask me, how did you discover this? Well, as a young kid, I was always interested in Stonehenge things and dolmens and big structures and big megaliths. I found it incredibly as a young child how people could do this with sticks and stones, build these mega structures. And so I questioned this, but when you grow up, become large, you think, okay, what am I going to do when I'm an adult? Okay, let's do something where I can earn money with. So I started studying technical. So and I was quite successful in this, and but my life slowly started to change because I became in a divorce and all kinds of troubles with my wife, ex-wife, and children. And I started questioning, what the hell am I living for? What I'm doing this on this planet? And all kind of philosophical questions. And then I started to remember, yes, what did I wanted to do as a kid? I wanted to know the origin of let's say Neanderthals and Homo sapiens and all these ancient people. What were they doing here, and how did they build these ancient cities and so on? So I stopped working and started to work on myself as a human being, to become a better human being, and not better for myself, but better for other people, and also to start researching again with the new tools I have from my study on ancient history. And so where do you start? You start just by reading all kind of stuff. And I stumbled upon Charles Hapgood's work. And Charles Hapgood talked about pole shifts. And I thought, that's interesting because it's also ancient. And when you look into the ancient past, you not only can look at ancient humans, but also at ancient geology. And Charles Hapgood talked about this. So I thought, maybe ancient humans were doing something with these ancient poles somehow. So I started investigating and putting all kind of math on it, and then I slowly started to discover a sort of pattern. And this pattern led me into another path, and I found out that Charles Hapgood's work was incredibly good, but it missed some crucial parts. And so I slowly started to work further on this theory. And after a few years, I could make a website from all my discoveries, and slowly, increasingly better, and more data. And here we are. After 8 years of working, I have a almost complete theory. So here I am with you.
Man, that's really great. I can relate to the origin of that. You know, going through something in your life that makes you think about what you're doing and reevaluate everything, and then decide, you know, I know what I'm passionate about, and then really just doing a deep dive into that. That's really awesome that you did that. And I can't wait to get into it. So you first started looking into the alignment of structures, right? This is how you started building the model.
Yeah. Yeah, exactly. So I thought about Charles Hepgood talked about Greenland, and when you look at Greenland, it's covered in ice, and you could question, why is there ice on Greenland? And you say, because it's so northerly located, close to the geographic pole. But when you look at Russia, or when you look at North America, it's also very close to the geopole, and this is landmass. So why is there nothing on these landmasses as well? And that's interesting. When you question these kind of things, you can also look at the former glaciers lying on Russia and North America and parts of North Europe, and you see suddenly that Charles Hepgood could be right, because this ice mass was far off from our current North Pole, and so it's sort of, how is it possible that Russia was not entirely covered with ice, while America was almost totally covered? And so Charles Hepgood was also struggling with this, and he said, based on all kinds of investigation he had done, he concluded that Greenland was on the North Pole. And I thought, wow, that is staggering if this is true. But can I somehow, because geology is mainly built from, let's say, data that is taken from the Earth. And there's no correlation of, let's say, geological data and human data. So I thought, maybe I can bring this together, because if this pole has been shifting and people are around for hundreds of thousands of years in all kinds of forms, let's say, hunting bears or mammoth or building structures, I don't know. And there could be somehow let's say, a small thread leading me into more data that is correlating with this with a geographic pole located on Greenland. So it's not an easy one, because you have to put all kinds of things at the same time in your head, like a juggler, juggler with all kinds of balls. So you have to play with all kinds of thoughts, and it's not better. It's better not to dismiss this or that. Just take everything in, and then look at what I'm having, and researching this as a let's say scientist who works only with data and not with, say, empirical evidence or somehow. So,
and isn't the problem with like mainstream's acceptance of these of Hapgood's ideas, and then kind of what you're putting together, is that it's too fast, right? Geologically speaking, like geology, they think of as long, very slow processes that take millions and millions of years. So
Definitely.
So to put Greenland at the North Pole, even within the last 400,000 years, this is way too fast, right? This is
way too fast.
Yeah.
But on the other hand, when we look at, let's say, the ice ages, you see a graph with all kinds of peaks and valleys.
Yep.
And it goes down 20 degrees, up 20 degrees, down 20 degrees, and so on, in all kinds of steps, lower and higher. This is also a geological thing. So the Earth temperature on the Earth has been rising a lot and going down a lot. And how the hell is this possible? Because, sorry, you have to put a bleep there. Because there is still no good explanations why the ice ages were so extreme.
Yep.
Yeah, that's kind of part of the common research groups.
So of course, geologists can say there's no evidence of the crust deforming so much and so on. But I can say then, but there is evidence that the Earth has been warmer and colder, not just a few degrees. No, it's way up, down. Not we're just panicking about 3 degrees, and this was 18 degrees up and down. So this is also geological evidence, but this evidence is more, let's say, non-physical, because it's just a graph. The graph is made from drilling into the Antarctic ice sheet, and then putting all this data together.
Yeah, it's proxies.
Making a graph, and they say this is just a graph, and it's no problem because the crust was always the same. So geologists won't see a problem in this, but there is a problem. This graph presents us with a real big problem. How can temperatures globally, not just in one spot, globally, going up and down with so much degrees? And then geologists say, but this is the Milankovitch cycles. Milankovitch is consisted of three parts.
Yep.
And this explains perfectly well why there is an ice age and not. But when you start to calculating this, it's just complete nonsense. It doesn't work. The mechanism doesn't work.
Is the Milankovitch would be too slow or not enough of an effect? What are you saying?
Not enough.
Not enough.
Because it's a little bit the same as stock exchanges. When you look at stock exchanges, you see all kinds of ups and downs, and they look pretty extreme. But when you look at the y-axis, this y-axis is just zoomed out a lot. And when you zoom, or let's say zoomed in. When you zoom out this y-axis from 0 to, let's say, 100, you see just a straight line like this. And it's the same with Milankovitch. Milankovitch consists of the tilt of the Earth changes a bit, like this, and that it wobbles around its axis, and that eccentricity becomes a little bit more and a little bit less. So you can make, let's say, energetic calculations, what this means for energy the Earth receives. And this is just a graph like this.
Okay.
But when you zoom in, you see this, and
it's going up and down.
I see a correlation over here. But it doesn't, it's not there.
Now, what about
correlation?
What about solar cycles? Could there be large solar cycles that we're unaware of that may have an effect?
Possibly, but there is no evidence for this. So, where's the evidence of solar cycles being so extreme?
Right.
We don't have them.
Yeah, the evidence would also be the same ice graph.
Yeah, that would be the. But you can't. Where's the correlation?
Right. Yeah.
That's the correlation.
Yeah.
But you do see a correlation with the eccentricity of the orbit.
Yeah, definitely. And that's interesting. And of course, you could say, oh, I see this B and C, you see this A, B, C, D, E.
Right. So we're just for people listening, we're looking at a graph now that shows the temperature changes based on the ice cores, and also a line of the eccentricity of the orbit
going back 450,000 years.
Right.
Yes, exactly. Thank you. And then you see this red line. This is let's say, the temperature going up and down. And then you see this plotted black line.
Yeah, and the ups and downs of both lines roughly correlate to each other.
Roughly correlate.
Yeah.
You could say, okay, I see a little bit correlation, and then around 100,000 years ago, I see this up, and then I see B and C. There's something just, let's say, it's sort of a break of the cycle,
right?
Because the eccentricity goes very much up, and the temperature falls down. But
Marty,
I have an explanation.
Pull that slide back up,
Yeah,
Marty.
Marty, don't be so stingy with the slides, man.
Okay, I was actually going to get you another one.
Thank you, Marty. You're doing
I'm
a great job.
multitasking here.
You're doing a great job, Marty. Thank you.
Yeah, so you can see the
Because
pattern sort of falls apart right there for B and C. That the spiking in temperature of B and C sort of coincide with a spike in the eccentricity of the Earth's orbit.
Yeah. there's the only correlation between, let's say, this eccentricity is one of the three parts of the Milankovitch cycles. And the two other, that is tilt and the wobbling of the axis, do not correlate. But this one correlates very well. Then you can start to calculate how much solar energy changes with this eccentricity changing. And it's basically zero. So how can this possibly correlate with temperatures going up and down? And there your explanation falls apart when it comes to receiving solar light. And the only thing I could find is that when eccentricity increases, the extremes increase as well. So the Earth comes closer to the sun and goes further away from the sun when eccentricity increases. So this, let's say, the massaging of the crust of the inner Earth becomes more extreme. And this could be one of the correlations.
With the crust shifting.
Yeah, the crust shifting. Exactly.
Huh, that's really interesting.
But yes, could be just one part of the explanation, because there could be more in this.
Right.
So
More,
now
more
you're talking
tidal
about-
forces.
Yeah, now you're talking about the physical mechanism.
Tidal forces.
Yeah,
Exactly,
okay.
guys. Yeah.
That's cool.
Okay, well let's go to the main part of at least the beginning part of the whole process, which is the alignments of all these structures. Let's talk about that. So how did you start looking into this, and what were you finding?
I started looking at the most famous structures. So I went to, of course, Giza, but Giza is an easy one. It points to our current geological pole. And what you find, but I was just working all kinds of ancient structures and not excluding or cherry picking this or this. And then I went to Teotihuacan and other sites. Exactly. What this basically explains, when you take two structures, pyramids of Giza and the pyramid of Ping of Han, they are both cardinally oriented. It means they are perfectly aligned as a square. So their northern face points perfectly directly to our current North Pole.
Geographical north, yes.
Geographical North Pole. When you draw these two lines, they intersect on one point, and this is our current geographic pole. And what is so important about this, because when you have one line, you won't find the geographic pole, because this line crosses the North Pole.
It passes the North
You
Pole.
don't know where you have to stop.
I see. Yeah.
And the stopping point is made by the second intersection. And this is just two structures. But when you do this with non-cardinally oriented structures, cardinally is a let's say a fancy word for being aligned to the wind directions.
Right.
So when you look, Americans should know this well, because when you go, let's say, north on the road, this road is not just going like this. It just goes to the north or to the east. There's no bullshitting around. It's just cutting through the landscape.
Yeah.
Straight on. And when you look at the White House, for example, it is also cardinally oriented. Just look in Google Earth, the White House, where your Colonel Biden is sitting. You see, it is perfectly.
It's squared to the cardinal directions, north, south, east,
Cardinal
west.
directions.
Yeah.
Exactly. So when you look at ancient structures, you find a lot of ancient structures that are not cardinally aligned. Oh, wow, Marty, great work.
So what do you?
This
What
is-
is
Oh, I
showing
see.
us
They're
here, Marty?
showing city street network orientations of all
yeah,
these. Okay,
yeah,
so
yeah.
Atlanta's north, south, east, west. Boston is
Yeah.
totally not.
Yeah. And I want to say something about when you look at the street plan of Philadelphia and St. Louis, for example, and Manhattan. It's another. It has to do with the geographical location of the island.
Yeah.
But when you look at Philadelphia and St. Louis, when they are founded, you will find that the magnetic pole was at that approximate location. So they used a compass.
Ah, okay.
They were using a compass to align things. Yeah.
Compass to align this the city. The rest of the cities are, let's say, mainly, I call this rational, or orientation of the city is rationally done. Just where is the east? Just go.
Man, this
go
is a
to that
great
direction.
graphic. This is fantastic.
Yeah, it's fantastic work. I used it from I have it on my is Mr. Boeing made this. Not the famous airplane maker, but just a researcher from some kind of, I don't know exactly what his location is, but Mr. Boeing made this did this work, and I used it to explain this little bit from
Wow.
how to look at orientation. And for example, Beijing, that is on the top middle,
Yep.
is built around the Forbidden City.
Okay,
And
so
the
that
Forbidden
one
City is cardinally oriented.
Hmm.
And it's a perfect example of how cities can grow around, let's say, a core.
Yes.
Yeah.
Yeah, so I recommend anyone listening, you guys are going to want to see this graphic, these two graphics that show the city orientations. This is really awesome.
You really have to delve into the website to find this. A lot of articles on the website where this is just one article.
So you've done this with ancient sites, and the basic, if I understand correctly, the basic idea is you get the entire site and you just try to find the alignment lines based on the foundations of the site. And then you're tracing those alignments of multiple sites all around the world. You're making them to just follow where they're pointing, and you've gotten multiple places of intersection.
Yeah. But first, when you start doing this, you have to define what let's say you have to define what orientation is.
Yeah.
Yeah, like what is the original orientation? Because a lot of sites may have very ancient foundations that are aligned to something, and then there's more modern structures built on top that may not have the same alignment.
Yeah. When you're doing a mathematical research, you have to define your borders or your limits. So you have to define, what am I doing? And I defined orientation as a square or a rectangular object that can be unambiguously 45 degrees clockwise and 45 degrees counterclockwise. And there is no unambiguous other way to define this. When I define this in a more broader view, I introduce an assumption. So this was the first step I had done. And then examining all these ancient structures one by one. And then build a database. And from this database comes a plotting graph.
So what do you mean? What do you mean 45 degrees clockwise and then counterclockwise? What are you saying there?
If you go any further, then you're right. Like if you have a square and you go and you turn it more than 45 degrees, then you're basically looking at a different face now, and you could say that it's
okay.
Exactly. And when you let's say want to orient or define a structure, okay, this must have been oriented to there or there. How do you know this for sure? because you say, okay, here's the door. And the door is facing 20 degrees southeastward. How do you know? How do you know for sure? You cannot know for sure because you introduce an assumption. And this assumption is that this structure has always been like it is.
Yeah.
And when you do this, it's fine, but you have to be aware that you're introducing an assumption that the structure always has been like this,
Right.
And it's never been otherwise. So this is what I've done.
So what you mean? You mean to say that you're not going to take the location of a door?
No. I have, let's say, a structure in my database is only square or rectangular.
Okay.
Yeah, thank you, Marty.
So if it was a circular structure with a door on the eastern side, you're not even going to use that one because it's circular?
No, it's an assumption. So, and where was this door originally oriented to?
Gotcha.
I don't know. So this assumption is left out of all the data. When I take, let's say, part of the White House you see on the screen, it is, let's say, the left wing. Then you can say I have 4 sides: north, east, south, and west. And I can turn this square in all directions I want.
Yeah.
Let's say I take the freedom to rotate this square in all kinds of directions. And when I rotate it, let's say 90 degrees left, counterclockwise.
Yeah.
What did I basically change?
Nothing.
Perhaps functionally you changed something, but for the mathematical research you changed nothing.
Yeah,
Right,
it has symmetry, so
Yeah.
you can turn it 90 degrees and it looks the same.
Yeah,
Okay.
exactly. And this research is when you're trying to wrap your mind around an intuitive theory, let's say Earth crust shifts, it becomes a little bit complicated to grasp your mind around the mathematical research. So you can try to we can try to discuss, let's say, the data and what it means for the interpretation of the data, what it means for the crust and for the ice ages.
So is what you're kind of getting at here is that because it's basically a square, how do you decide which way they thought was north at the time of the building?
It's a good one. Yeah, absolutely. You can say, okay, Giza is an ancient pyramid, an ancient structure.
Yep.
And this one is oriented to our geographic pole. So there is a trait to orient something to the cardinals, because we see this everywhere. We see this not only in the White House, we see this also in Giza, we see this in the Vatican. Thank you, Marty. We see this in Taj Mahal. Basically, most of the observatories where you observe the sky are cardinally oriented structures.
Yep.
Why is this? I don't know. There must be a reason to do this.
Well, if it's a telescope, I mean, when I set up my telescope, the first thing I'm supposed to do if I'm going to get my setup correct is face it north.
Yeah.
Right.
Yeah.
It's your anchor point.
Yeah.
It's something so logical you do that it's hard to even to discuss this.
Right.
When you build, let's say, an observatory to look at the sky, and I just put down the walls and I turn it 10 degrees to the left. Why am I doing this? So you orient your structure to the cardinals, to the let's say the astronomical features of our sky.
Right. Yes.
Yeah.
All right, let's take a quick break, and we'll come back and keep discussing this.
Okay.
Thanks, Maarten. This is awesome. We'll be right back.
We're back, ladies and gentlemen, Brothers of the Serpent podcast, here with Marty and Maarten. Maarten from the Mario Buildreps website, and looking at all of his research. And so we're going to continue on. Maarten, go ahead.
Yeah. Where were we going?
Well, we were looking at the methods for determining the alignment of structures, and then I guess where we're going is how they, after you started plotting all of these on a map, how they correlated, and that there were clusters that correlated to possible different poles.
Yeah, it's a good one. So when you I have defined what is orientation and what limits you are, then I started looking at structures, ancient structures all over the globe, Western Hemisphere, Eastern Hemisphere, and put it in a database. And I separated these two. Let's say, let's have a look at the West Hemisphere. So this down from North America down to Peru, and then from Europe all the way to China. There's a large collection of ancient structures. And when I look at East Hemisphere, so that's from Europe to a little bit on Africa and then Egypt and Iraq, Iran, and all the way down. There's a lot of, yes, exactly. This is just two structures, but they basically point out what is happening. So we have an ancient pyramid in Wu of Han, in China, and in Teotihuacan. And when you check their alignments, their north faces cross over Greenland.
Right.
And I want to say something else, because you see this China, there's the location and 352 degrees. This is basically an orientation of -8. And in China, you have only cardinally oriented, and suddenly the pyramids make a step of -8.
Oh, wow.
And that's an intriguing step they are making.
Now,
And there might be something in between, but there's not much. They suddenly make a jump.
Okay. Have you looked into any like archaeological data correlating the possible different ages of these two sets? Or is there anything that correlates? No? Okay.
No, not in the specific situation of China, but when you look at archaeological, it's a difficult word for me to pronounce. Archaeological things about Teotihuacan. When you go today to the site, it looks neat and clean.
Yeah.
But this is not the way it has been. It was covered with a lot of soil.
Right.
Yes.
And they needed about 75 years to clean this site up. Imagine this is a life work. But it seems like no one is talking about this. What was happening here?
Yeah, it is strange. They were basically all buried.
Yeah, all buried.
Wild.
Yeah.
So you find two sites, as in the previous slide, that point to a different pole. But I mean, couldn't you just add a different site that pointed in a different direction and say there's a pole there?
Yeah, this is basically what happens. So when you look at this graph, you see a lot of dots, and perhaps people think, oh my God, what I'm looking at. You see basically an x-axis and two y-axis. And the green dots are mainly above the x-axis, and the red dots are mainly below the x-axis. And the red dots are less extreme than the green dots.
Yep.
Well, this graph is a little bit older, so the database has grown, and the red dots have become more extreme below the x-axis.
Yeah, you're saying by extreme you mean there's a greater grouping of the green dots than the red ones. Yeah, okay.
Greater grouping of the green dots than the red dots. So it seems that let's say the trait to do something, whatever it is, was more consistent in the Western Hemisphere than on the Eastern Hemisphere.
Okay.
Yeah.
Now, here, from my understanding, like of this graph, as you start creating more intersections, they create these nodes. Yeah. And then once you put in a great number of them, you start to get node clusters. It starts to tell you something.
Yeah. Okay, so the graph that he's showing here is showing you longitude and latitude degrees, the angles, and then the dots scattered about would be the orientations of the various structures and their intersection.
Yeah, there's an extreme clustering and of ancient sites over these on this location, and this location is where Greenland is on. So this is basically the map of the Earth, and Greenland is on this longitude and latitude.
I see. Okay.
Yeah.
So, and
Marty, do you have the graphic we were looking at? Yeah, with the globe.
Yeah, I'm going to pull that up now.
Okay.
That was showing how, in other words, that was just where the intersections just happened to cluster.
Yeah.
And then they end up forming this once you overlay it on the planet.
Yeah, there we go.
Yeah. And so the first line of thought is when the geographic pole shifts, it somehow intuitively must have consequences for our climate. It has
absolutely
somehow. Yeah, it's an extreme climatic change.
Yeah,
and so where do you look for climate changes? And you look, of course, at the
ice cores,
at the ice age graph. And when you plot the distances between the poles, so not the poles itself, but the distances of the poles, when you plot them over the distances of the ice age graph, you see there is a match. And it seems to the viewers perhaps that they are one, but they are not one. They are two separate patterns that match on each other.
Right.
Distance over time.
Yeah. So this is basically, this proves for 99.6% that the shift of the geographic poles that is defined by ancient structures, by the foundation of ancient structures, you can find the age by looking at the ice age graph.
There's a correlation between.
There's a correlation, yeah. And then, of course, okay, at which point is the crust shifting, and at which point it is stable? It's a good question when you look at this graph. Is it stable at the tip or at the bottom in this graph?
So in other words, is it stable at the spike in temperature or the valley, like the low temperature?
Yeah, exactly. Where is it stable? And then you, of course, you start with, on the right side of the graph, our current pole, our current climate. So you're back on the red.
Let me pull this. I think this one might.
Yeah, it's a good one.
Yeah.
Yeah. You start at our current time and age. At time is 0, pole 1. So somehow our climate has bounced up from the last glacial maximum and then became stable for some kind of mysterious reason.
Yep.
Because if you ask a climate scientist why became the climate stable some 12,000 years ago, he will say, I don't know.
That's right.
Yeah.
But it does suggest,
stable.
does suggest, I mean, if pole stability has to do with the high temperature, that would kind of make sense for, because as far as we know, the pole is fairly stable right now.
Yeah.
And has been for a long time.
Yeah.
Yeah. Not the magnetic one, but the geographic pole is.
Yeah, the geographic pole.
So you start thinking, okay, you have a downward flank of the temperatures going down, and you have an upward flank of temperatures going up. So it's, if you look through all the difficult things, you see basically that this pole is stable at the upward flank, and the pole can be unstable at the downward flank. And then upward flank stable again, downward flank unstable. So here's a pattern. And this pattern is very consistent. And of course, you have to define somehow natural temperature variations.
Yep.
And I've done this. So you see these green bars and this red bar. I made all kinds of difficult math on this. Try to find correlations with how much shift correlates with the temperature, and does it work on the changes I found. And this is a consistent pattern. So it does not only match in, let's say, amount of shift, but it also matches on the patterns. And
so let me ask this. So what you're saying is the distance between the clusters of ancient sites that correlate to possible pole positions correlates with the magnitude of change of temperature on this?
The distance between the poles that are indicated by the ancient sites matches with the temperature shifts. Is that what you're talking about?
Like the amplitude of the temperature shifts?
Yeah. But you have to, let's say, subtract, because you're looking at massive time frames.
Yeah.
You have to subtract some natural possible variations in this.
Yeah.
And how much variation is this? There's all kinds of research on this. And I found that 2.8 degrees is the most, let's say about 3 degrees is the most reliable variation.
Like non-crustal shift variation. And then when you get a crustal shift, you get it hugely.
Exactly. Yeah.
Okay, so the steps are, you look at a bunch of ancient sites, you determine their north, south, east, west alignments, and then plotting those north alignments shows you a bunch of different possible previous poles.
Clusters around positions.
Clusters around poles, and then you find out that, like, amazingly, the distance between those pole clusters correlates with the temperature shifts that are being shown in ice core data.
Yeah,
as well as the time between them, right?
The time between them, yeah.
Yeah. Yeah.
So, like, you have a small distance of a former pole shift. There's 2 points right there that are right in the middle of Greenland that are relatively close to each other, and those correlate perfectly with a much smaller shift in temperature in the
exactly.
Or the duration between those.
The duration, yeah. Okay.
But this, I want to say, I only correlate, let's say, the vertical patterns. So time follows from the correlation of extremes in peaks and valleys. You get this?
Yeah, so you're only doing the time correlation here. Is that what you're saying?
Okay.
No. I am only doing the degrees correlation. So I only match a pattern. So I can start. It's in a few steps. I start from a pattern. I see four distances. I can say this is a pattern. I don't measure the distance. I have a long distance. I have a short distance, a medium distance, and then a large distance. And this is a pattern, XL, S, M. and then L.
Okay, I see. Yeah.
And I can
the number of degrees that it moved.
Right.
Yeah.
So
the number of
extra
degrees
large,
it moved.
small.
Exactly.
medium,
The number of degrees
large.
it moved. And this, let's say, not attaching something like kilos or meters to it, just as a number. I match the numbers also in the graph. So I have let's say, a pattern match. And I do not say anything about temperatures yet or whatever.
Right.
I see patterns matching. And from this pattern match, I can say with a probability of 99.6% that these poles are as old as I am showing in the graph. So, for example, pole 5 must be, with a probability of almost 100%, must be between 240 and 270,000 years ago. No, sorry, pole 4.
According to the dating methods used in the ice cores.
In the ice cores, yeah.
Exactly.
So then then you can turn around and say, well, that implies at least that the original orientations of these sites that point to that pole are at least that old.
Yep. Some of them, you have to, of course, have to apply a probabilistic method.
Yeah. Because
they could have, by accident, have oriented something to a pole. It's always possible.
Right.
You have to leave out. You have to keep in, let's say, this doubt that something can be pointed to Venus star or whatever.
Right.
So you have to make a probability match of this, and this is what I have done. And this is why it took me so much years.
Here, when we see these in these point clouds here, and I know that YouTube, or only the people that watch this on YouTube will be able to see it, but when you look at the nodes that are created by these intersections, you see that there are bands of these.
Yeah, there are bands. Yeah.
So are these, and then of course you see the clusters within the bands that are highly suggestive of some alignment, right? These are not random. They seem to cluster in certain areas, but
it's not random.
Right. The extraneous ones, the ones that are outside of those large clusters, are those, but they're still in bands. They still seem to follow these bands. So
exactly.
Suggestive of potentially other astrological alignments.
Everything is always possible, but because I have a pattern matching with the ice age graph, I can say I have geological evidence for this match, because this matches that this is a geological event.
But also, in order to get this point cloud, each point on this cloud has to be the intersection of two structures, right? How do you decide which structure intersects which structure?
We have to go back to the other point, not point cloud, the other graph. Marty, you know this?
Because I would assume you figured some mathematical formula to do that, but
yeah.
It's got to be.
Is it this one?
Yeah. This is, I can pull up another picture, maybe. But if you look at the green dots,
I'm sorry. Let me pull that back up.
It's okay. It's okay.
It's not okay, Marty.
If you look at the distribution of the green dots and distribution of the red dots, you can, let's say, I define one point of all these green dots. What is the average location of all these green dots? And what is the average orientation of the green dots? I can do the same for the red dots. And so I get one location and one orientation of green, and one location and one orientation for red. And when I make the intersection of these two gathered points, I find an intersection on Greenland. And what you can do from that step is draw a line from the current geographic North Pole, from which we are sure where it is, down to this average point, intersection point.
I see.
And I get a line.
That gives you a path of the drift.
Exactly. It gives me a path of the drift. So I can make a bend. Let's say, okay, a bend of, let's say, 10 degrees east and 10 degrees west over Greenland. And I can start to calculate the density of the intersections along
with
this
that
path.
line.
Okay.
I see what you're saying. So you get the average line. The average of the point cloud gives you that one point over Greenland. Then you draw a line between that point on Greenland and our existing pole, which gives you the path of drift. Then all you need is each individual structure north alignment and where it intersects that line.
Yeah.
Okay.
So this is basically a sort of bend, and then you can say this is made from all ancient structures. This is how it looks like, and you can think about, what does this mean? What is it? What I'm looking at, and the step that I made is looking at patterns, not at degrees or kilos or meters or whatever temperatures. Only looking at pattern matches. And the pattern that matches with this are the extremes of the ice age graph. And then, because I find a match of 4 distances on 4 extremes on the ice age graph, I can calculate the probability for this match to be one-on-one, connected to each other. And from this, I made a step that it is 99.6%. So it's not a figure that I invented. It's just the math that comes from it. And so I can define in a mathematical way how old these point clouds are.
Yeah, and again, that's based on the dating methods used when they're analyzing the ice cores and geological data and all that.
Yeah, exactly. And then,
which we could call into question, since we can call into question anything over here, Brothers of the Serpent podcast.
Yeah, it's great. Do this.
I think you pointed out last time when we were looking at similar images to this, you were showing how the older pole points are more, what did you say? They're more dispersed.
Scattered.
Yeah, they're scattered because because the structures have had longer to degrade.
Yeah.
And also the warping of the crust itself over the long distance of time. Yeah. So I would like to share an image with you real quick. Now, since we're talking about that, let's see. So this is we're looking at the Western United States here.
Mm-hmm.
And this is the
mountains. Yeah.
Yeah. This, you can see this little curve right here.
Yeah.
So I learned this from Randall Carlson, that this was some kind of caldera or something, right? It's a volcanic.
Caldera, yeah.
But it is drifted.
Yeah, it's a path of the hot spot underneath. Yeah.
Yeah. So it started here.
Yeah.
Right. And now, because of crustal motion, it's like the hot spot has stayed in the same place underneath the crust, but the crust has shifted over top of it and left this pattern of this hot spot.
Possibly.
I think that's standard model.
Yeah.
Yeah.
So it's interesting to see that, like, let's say this is not a factor of crustal shift, but this is just the normal
plate tectonics. This is considered to be very old, this path.
But you can see how this could slightly change the orientation of things over time without the entire crust shifting.
Of course, there's always. I never want to pick one theory and say this is the theory that explains everything.
Sure,
because this is not how it works. Because you still have tectonic motion, you still have comet impacts, you still have the sun varying in all kinds of activity. So you have a lot of things going on. And I do not want to claim my theory explains everything. It's just an amazing pattern that I found. And I can correlate things to each other and say, this matches. What do we do with this?
In the context of the alignments, the slow geographic processes actually make the problem worse, because then that would be suggestive that the structure's being yet older.
Oh,
for sure.
This would be a problem.
In that graphic that you just showed, Kyle, there appeared to be a similar pattern just to the left of that and a little bit further down. There's a kind of see the same sort of, see there off to the left of that one you're pointing at? Yeah, right there. You kind of see that same.
Yeah.
If that's is in fact what we're seeing.
Yeah, I don't know.
There seems to be.
I don't know. I'm seeing something similar to the north as well, but I think that Kyle said it correct. It's a caldera that moves.
It's like a Yellowstone hotspot, I think, or something.
Yeah, so there's other geological.
But I want to say something else, because I see a pattern to the left as well. Let's say a sort of this runway going
north,
going in the northeast and the northwestern direction.
This thing here?
Yeah, exactly.
Yeah.
So I can also say it's a caldera. When you go to the right again,
right,
it's a caldera that never moved. Whereas the evidence that this moved, because I see more flat areas in all kinds of directions.
Right, but there's other geological evidence on the ground there that, as far as like basalt and all that kind of stuff.
I do not want to pick on geology, but geology doesn't have proven to be very consistent in the explanation of things we are looking at.
We like to pick on geology all the time.
Oh yeah, we do all the time. I think all that Kyle is pointing out here is that this already is a known process. They just in standard model geology, it's just much longer.
Right. They tell us that the crust shifted here. Yeah. Right. That's all I'm trying to point out, that this is not completely outrageous. It's just a matter of timelines that, standard model geology wants to argue and say, oh, that's ridiculous that the whole crust would shift.
They have a problem with it with rapidly. The scale of
possibly. But are there more places where you find this moving pattern?
I don't know. I know about that one, and I just wanted to show you because it again, my point in showing that to you is that this is accepted by the standard model, that it has shifted in this strange way, right? It's turned a little bit, it's moved up and then down and then up.
Yep.
So I just find it interesting. It's not.
But it's also we're also talking about a time scale of hundreds of millions, or is it tens of millions of years?
I can't remember.
One? Yeah, it's a long time scale. So
they think it's a long time. Yeah. But of course, so going back to what you're looking at, these clusters, the fact that these orientations of the ancient sites cluster in various spots tends to suggest that the pole shifts and then it stops. And it's stable. Again, going back like you were saying, there's a stable period, and this is when people will be building stuff and they're pointing at the pole, and then again it shifts and perhaps there's a climactic change and maybe a bottleneck in civilization, and then when it stabilizes again, then we start building stuff and aligning to it.
Yeah. This is what I'm suggesting, and maybe we have to talk about in the next break what kind of mechanism I am suggesting.
Yeah, we could talk about the mechanisms, and
I think maybe also we need to maybe point out is the time frames that we're talking about. When do you believe each of these former poles was present? And then we'll get to the mechanism, because I think the dating of
bring up the solstices, because we talked.
Oh yeah,
right.
That's a big one.
Yeah, that support additional supporting information. That it's not just based on.
What was your original question last time? You said, was there some other thing that you could check?
Yeah. So the question was, typically with a theory or a hypothesis or something, it makes predictions, right? If you have a hypothesis that suggests things are happening in a different way, then there are other predictions that it would make. And so what other predictions would a shifting pole make? And have you looked into that?
predictions for the future. You mean?
Well, no, like a scientific prediction, like to say, basically what you're. When we talked about this last time, you pointed to the solstice alignment.
If you're asking me the question like this, I am saying the Earth will expand again. Boing.
Well, I think what he's getting at is your correlation with the changes in the solstice angles.
Right. It would if the pole was different to this structure that was aligned to a different pole, it also would have different solstitial.
This, of course.
That's the type of prediction I meant.
Yeah. So you can look indeed to a structure that is oriented to one of the ancient poles, 2 to 5. So 3 poles on Greenland and 1 pole just south beneath Greenland. You have orientation to one of these poles. You can calculate probability that this match could occur just by chance. This is one step, and then we can. I made the let's say the calculations. What kind of solstice angles you will have in this constellation? So, meaning orientation to this pole, meaning that the latitude was different, and so that the solstice angles of this typical location would be different.
Right. And in the event that the pole was in a different place, the solstice angles would also be different than the modern pole solstice angles in that place.
Yeah, sure. And so when I look at an ancient structure, for example, oriented to pole 3, then the latitude would be different. I can recalculate the solstice angles for this typical location and look if these angles are somehow encrypted in the structure. And in many cases, I've found there is a match on this. And that's, of course, interesting.
Right. So you calculate what the solstice angles are on a specific structure, or what they would have been at a different pole at a different latitude, and then you find something like what would you find, for example, like windows or doorways or some. How do you find that solstice angle represented?
Mainly the size of the structure. So the let's say you have a stairway. You walk up the stairway. You stand upon the side of the structure. And then look at one corner and look at another corner. And you will find in many occasions, that there is a correlation between the solstice orientation and the solstice angles of this typical structure.
I think that was a very telling example of this is your work on Stonehenge.
Stonehenge, yeah.
Showing Stonehenge at its current geographical location.
Yeah. All right. Well, hey, before we get into Stonehenge, let's do that after this next break. Because I would like to go into detail with this, and I also want your explanation of the sites and how you keep some sites out initially and then bring them back in.
Yeah.
All right.
Okay.
So we'll take a break. We'll be right back.
And we are back, ladies and gentlemen. Brothers of the Serpent podcast, once again joined by Marty and Maarten. And we are discussing Maarten's excellent research on the Mario Buildreps website and YouTube channel. And we're trying to go through all of his data, which is not going to be able to happen on one show. Maybe we'll have him back sometime. Maybe have some Patreon episodes, possibly. We'll see. But yeah, we've been discussing in the breaks Maarten's work and all the possibilities and everything. And I just want to say before we get started here that I have no problem with your timeline, making some of these sites very ancient. You've said multiple times, like, how long can rock sit in a place after somebody's built a structure out of it? Yeah, it can sit there a long time if it's not disturbed. It is interesting to think about what would happen to a structure, even if it's built out of massive stones, during a crustal shift. If that crustal shift is catastrophic, probably the structure won't survive. But then people can come and find the foundations and rebuild.
Yeah, exactly.
And then the those newer structures will still follow the original foundations. We know this happens, even in accepted archaeological timelines. We know that people reuse ancient sites. And so I don't have a problem with that. But let's going back, let's talk a bit about how you said when you were finding alignments, you said you started with you were saying, okay, this structure is circular. There's no way to even find an alignment here. Let's leave that one out for now. But you did eventually start re-including them, right? So talk about that.
Yeah, sure. So after I defined, let's say, the poles, I can look again at other structures that do not fit into the theory of square and rectangular structures. Let's say I can start looking at Stonehenge. Stonehenge, interesting. What about Stonehenge? Because there are theories about Stonehenge, but they leave, let's say, 60 or 70% of the stones workless. And so I started looking at Stonehenge.
Leave them worthless? Is that what you said?
Worthless, worthless.
Worthless,
yeah, worthless. So what about all these stones sitting there? There's no explanation for why the symmetry is like this, but the symmetry does not make sense for our current pole position.
Right.
So I had found 4 poles. What they do? What is the symmetry axis of Stonehenge? The symmetry axis is there's only one symmetry axis, and it's going right through the middle of the big monolith and the heel stone. Then I have 4 positions to correlate them, so I can look at them. And what did I find is it correlates with pole 4, and pole 4 is incredibly old, 250,000 years old.
Yeah,
plus minus a bit, of course. And then
what we're looking at here, we originally had a graphic that was showing that there weren't proper correlations in alignments with the solstices, sunrises, and everything, and with our current geographic pole.
No,
but if you go back to pole 4, now we see that the alignments do work through the stones, and it makes much more sense. That's the point.
Yeah. Suddenly, it happens. Something happens. Something incredibly happens. That when you correlate Stonehenge to pole 4, you have, let's say, the orientation is rational to a pole, but also the latitude of Stonehenge would have been different.
Right.
And because the latitude was different, the solstice angles were different. And so I calculated the situation for Stonehenge, and suddenly it appeared that and in the picture you see that the sun was shining through an incredibly tiny split. And that was the time of the year at that latitude, at that time people lived there, that the solstice was there. And so the time of year was changing. And yes, of course, when I look at this as a mathematical trained engineer, I can calculate probability for this constellation to fit coincidentally, and it's just not there. So I can say this is it. This is how it worked.
So basically, what you did here is because you can calculate what the angles of the solstice, sunrise, and sunset would be where Stonehenge is now, according to the modern pole, you can see that those 4 sets of large stones inside the circle don't correlate to the solstices in modern times. But if you go to the pole 5, right? Is it pole 4? Pole 4.
Pole 4.
Then you change the orientation, you change the latitude accordingly. Then you can calculate the solstice angles at that new latitude, and it works with all those.
And it works.
Stones.
So you have a match. Let's say puzzle pieces that start to match. One puzzle matches, another puzzle matches, and it's an incredible fit. So my conclusion is that this is how Stonehenge worked, and this is how old Stonehenge originally is. And there was a growing ice sheet, and growing ice sheet. Now this is an incredible, good animation. Yeah.
Okay, we're watching an animation here that Marty's put up.
Yeah, you had a very tiny split through which the sun shone during the solstice. 250,000 years ago, plus or minus, let's say 10,000 years. And there was a growing ice sheet at the time that also grew on England, the northern part of England, but it never became low enough to threaten the ancient site of Stonehenge. So we don't know what people have been building further to the north.
Yeah, okay.
Yeah.
Yeah, because the ice would have destroyed anything further north.
Yeah.
Yeah.
Absolutely crushed everything.
Right.
Yeah. So it's an incredible, and I still remember that I was working on this, and I of course, my wife, I told her every day my progress, and of course she very patiently listened to my my stories about Stonehenge and ancient structures, and sometimes she said, "I now have enough of this, all this talking about." And I said to her, I found out how Stonehenge worked and how all it really show me this. I made all kind of computer simulations. She said, "Oh, that's incredible! Wow, you have to tell this to the world." I said, "No, let's wait, because it's. I'm not yet myself not ready for this, because I'm also conditioned." Like you all, for Iron Age and Bronze Age and then Stone Age, and then
you mean it was it was too old in your own mind? Is that what you're thinking? Yeah,
too old in my own mind. Yeah. Sure.
Too long ago.
Yeah. But the situation is that this is too high. Let's say the chances are too low for this fit to be just a coincidence. And so I had to do something with this.
Have you? I'm curious if you tried looking at the shafts, the orientation of the shafts in the Great Pyramid.
No.
Okay.
No. But I'm pretty sure that the Great Pyramid is built during our pole.
Right.
And it can be maximum at the age of 26,000 years old. And that is, of course, already...
Yeah, it's already way outside of it. Yeah. Yep.
Way outside. But let's say if you draw a Gauss curve, you will find something around 14,000 years. Is the most probable age for Giza to be 15,000 years old. That's the most probable age you will find. And
well, I've been there. It feels very ancient. But like you were saying in the break, it's 1,000 years is a long time to us.
Too much for us.
So how can I stand in amidst something that may be either 4,000 or 14,000 years, and can I tell the difference just standing there?
it's too much for us.
Yeah,
we cannot comprehend 1,000 years or 10,000 years, 100,000. It's all just numbers you're looking at, and when you're putting yourself as a human being in this time frame of grandfathers and grandfathers, and then going back to the 17th century, we are just lost in time as a human being.
Yeah.
With our mind.
We live in an area that has a lot of fossils. And it's sometimes I'll pick up a fossil and I'm holding it and I'm like, this is supposed to be 70 million years old or older.
Yeah.
And you just can't grasp that I'm holding an oyster shell that was supposed to have been alive over 70 million years ago.
It's just a number.
Yeah, it's a number, but there's no way to comprehend it. Yeah.
No, we cannot. And I think this is the reason why our history started from now back to grandfather, and then to an empire, and then to kings and queens and rulers, and then somewhere back to ancient Egypt and Mesopotamia, perhaps, and then you can write down all kings and queens and rulers. And then you are somewhere around 6,000 or 7,000 years ago, and then it stops. Yeah. Just lost in the midst of time. A long list of people. But if you're thinking in people, you will somewhere lose your track down the road, because it's too long.
So that's making me think of Göbekli Tepe and Haran Tepe. Have you looked at those sites and tried to correlate? I mean, they're round as well.
Yeah, they're circular.
Yeah.
Have you?
I find the same matching patterns, and so orientation of Göbekli Tepe. Not all ancient sites correlate with the pole, but most of them. And this, of course, is already a match. And
they match the current pole. Is that what you're saying? The current one?
No.
Okay.
The old poles, no. Göbekli Tepe definitely does not correlate to our pole.
Okay.
Marty, good, great.
Oh, wow. Look at that.
Yeah.
Yeah.
A, B, C, and D.
Yeah, A, B, C, D. And so it's Göbekli Tepe is situated in Turkey. Turkey is on the west and on the eastern hemisphere. And so if it correlates to a pole, it has to be counterclockwise oriented. And you see this clearly on all the stones. It is consistently counterclockwise oriented.
Yep.
And
so that's suggestive that structure A is the oldest, right?
Yeah. And also you see a sort of pattern of the younger the structure becomes, the more stones are still left. And so A is the oldest, just a few stones.
Wow, look at that.
And then B, you find a little bit more stones. And then C and D, you find the most stones. So there's also a pattern in this. And it's incredible. It's also a match. And I can keep on going with all this Chichen Itza and all the other sites. They all match. They all are consistent.
Well, thinking about Göbekli Tepe, though, just going with this idea, it would sort of make sense if this was, I know we're talking about very long timescales, but say there became a tradition there after the first pole shift that they bury the site to preserve it. To say, okay, that's the old one, bury it, we make a new one, and then
maybe, I don't know.
I know, it's just, I'm totally just
maintain a tradition for 100,000 years.
I know, it seems really out there, but
if you look at the explanation of archaeology for thank you.
Wow.
Archaeology for why Göbekli Tepe is buried, they say they backfill the site. But if Göbekli Tepe is really 350,000 years old at its oldest, or maybe some parts older, then it's just naturally buried by time. A long, long time buries the site, and no one visited the site anymore. after it was left. And so slowly, flora and fauna buried this location. And when you look at the area of Göbekli Tepe, you see the whole area around Göbekli Tepe is also at the same ground level. Only Göbekli Tepe is deeper. So if they would have been building Göbekli Tepe and then backfill Göbekli Tepe, what about the surrounding area then? So there's no logical explanation for Göbekli Tepe.
Yeah, and it also doesn't, I mean, if they really are pointing at all these different poles, I mean, that just suggests that the site itself has been active for hundreds of thousands of years, which is just, that's wild to think. And then building in the same styles over that long period of time, I mean.
Yeah. And stone is just sitting there for easily for millions of years, maybe. Or
but it's,
in this case, 100,000 years.
It's limestone, isn't it?
Yeah.
Which is
so.
pretty soft.
So. Yeah. I'm not directly into materials, so I'm only into the math. And honestly, I do not care what kind of stone it is made. But when I look into a specific site, I am intrigued, of course, by all kinds of tool marks. You see, I think, oh wow, that's incredible. Tool marks on this kind of advanced tool marks on this hard rock. How is this possible? And of course, but for the method itself, I am mainly busy with patterns and orientations and matches that I find.
Would it make it easier in your mind, do you think, if we just say, okay, the pole correlations are probably correct, but maybe the dating, which is based on the ice core stuff, is wrong, and maybe it is faster. Like maybe they aren't that old, but that there's actually shorter time periods in between these shifts. Would that make it easier in your mind to understand? You know, is that a possibility?
No, because you then stumble onto difficulties, because you stumble upon Giza.
Yeah.
We as between us, we know for sure that Giza is not built by, Pharaoh, this or that. We know this for sure. It's older than that. The Pharaoh found this and said, it's mine. Everyone who claims otherwise will be killed. And if you say if you believe and tell what I'm saying, you will be rewarded.
Yeah, I don't have I agree with that. I'm just saying.
So
I'm saying
what I'm saying is that you stumble upon Giza. Giza is oriented to our current geographic pole. How old is Giza?
Sure.
So you say, okay, don't know. Let's say 5,000 years, 10,000 years. And then you go to the other sides that are not cardinally oriented.
Yeah.
What about them? How old are they?
Yeah.
Because they might be pointing to another pole. 30,000 years. But where is if the pole has shifted, where is the climatic evidence? You are finding them in the ice cores. Right. Climatic changes. And year for year, you find a match. And I always doubt in everything that I'm doing.
Yeah, I think what Russ is pointing to is not basically he's asking if take the idea that the standard model methods of dating the ice cores could be flawed, and that they are actually not, these climatic changes are not as old as the standard model accepts, and maybe they were much more recent in our past.
No, there's not millions of years, but maybe hundreds of thousands of years.
Well, I mean,
we're only talking about hundreds of thousands of years according to the standard model here, like going back 450,000 years.
Yeah.
But could that be wrong and it be much more recent?
I mean, this is pure speculation.
Yeah,
I'm just saying, you know, if the one thing that
the point that I wanted to explain is that if it would have been more recent, for these geographic changes,
Yep.
then you must find climatic evidence for this.
Yeah, and that's what I'm saying. That the climatic evidence in the ice cores is actually all much more recent. That's all I'm saying.
Yeah, exactly. And but then you have to find somehow. It is a possibility.
Yeah,
it is always a possibility. And then you have to find somehow to look at patterns that might be matching with these pole positions somehow. And I didn't find them, but perhaps someone else finds them. Say, Maarten, what do you think of this or that? Say,
yeah, Marty can find them. I'm saying that all of your, we can move past this, but what I was trying to say really is that all of your pattern matching still fits, right?
Yeah,
you don't have to change any of that. I was just saying because your pattern matching also is you're matching the pattern to this graph of the ice core data that is showing a timeline of climate shifts. And all I'm saying is if that timeline is actually much shorter, you don't change anything else.
Like in other words, that the standard model dating is too long for those climatic changes.
They are inclined to make these things as long as possible.
Right.
You mean that ice core dating could be wrong?
Yeah,
that the dating itself could be wrong, and it could be much more recent and much more frequent activity.
Yeah.
So that maybe we were only looking at 50,000 years or 60,000 years of.
Honestly, I doubt it because you have a clear pattern of like the same as in trees.
Yeah.
Right. Then
rings.
The rings of years.
Such clear boundaries of 1 year, another year, just counting the years, and then you come to 450,000 years. And
okay.
So, and the soil deposition as well.
Also, and because Antarctica is a position where it's one part of the year dark and one part of the year light, so it's a returning. It returns consistently.
Yeah. So a high level of confidence in the dating of the ice core.
Absolutely. Yeah. So I wouldn't. Of course, you always have to leave room for doubt. But in this case, I think you have to have very, very good case to doubt this.
Okay. Cool.
Yeah.
All right, there we go.
Yep, no doubt there.
There we go.
So here we're seeing roughly the time periods for your estimations of these former poles.
Yeah.
And they're quite different than the standard model dating for these structures.
Sure. And you see very consistent periods of stability. Pole 1, 26,000 years ago, according to my method, the pole became stable. And so civilization started to thrive again. And then before that, there was between 26,000 and 130,000 years was there instability. So it slowly disrupted civilizations. What happens when the crust deforms and latitudes very slowly change? It does not mean instability for now or tomorrow. It means instability for the very long term. And when you want to settle as a civilization, the civilization will settle on quicksand. So you build a city, but the city just becomes unstable. It becomes flooded by rivers or sea, or just sea level dropped. So city moved again to the shore, or the crust shifted to another latitude slowly, and then they decided, due to crop losses and extreme weather extremes too, to move their civilization again to another. So this is a very slow process. This is not about the human being itself. It's about civilizations in big numbers that slowly migrate, slowly change, and over 100,000 years. So that you're talking about 4,000 generations. 4,000 generations over this, between the period of Pole 2 and Pole 1, to live on this planet and to migrate and to survive. And then before that time,
it's also a cold period, right? Or what is it? What's the temperature like, the climate like during the crustal deformation period?
Yeah, that's a good question. Because when you look at, there are very good graphs drawn by Vostok, by the Russians, on the South Pole. And they have made, let's say, the correlation between temperature, CO2, and dust. So dust clouds in our atmosphere.
Yeah.
And this, when you look at the period of alleged instability between Pole 2 and Pole 1,
yeah,
you see over this time period of almost 100,000 years, you see enormous dust formations. So it means the temperatures drop. Parts of the heaven were a little bit cloudy, full of ashes, perhaps. And so it must have been colder, perhaps 3 degrees colder than during stable times. And this also would have encouraged civilizations to look for better places. And this is why I think we see so little evidence of, I find so little evidence of civilizations to thrive in between these two positions. There are ancient structures oriented in between the poles. Mm-hmm. They are always there. There is a pattern, but it is so little, so less. It's, let's say, you go from Northern Africa, down is a populated area, then you go through the Sahara, you almost see nothing.
Right.
And then again, you start to see there's also a little bit the same, but then in
so during the shifting period, when it's also colder and things are more difficult, more catastrophic, not necessarily catastrophic, but things are in motion, in change.
In motion, slowly.
Yeah. You're saying that these long-term building projects were less likely to take place and thus be cardinally oriented to wherever the pole was at that point. Whereas during the stable periods, it was more likely that people were able to do agriculture, that they were able to stay there a long time, and so they were able to do building projects, more of them around the world, and thus you have these clusters of pole points.
Yeah, you said it perfectly well, Russ.
That's my job. Thank you.
Yeah.
It's interesting that the periods of stability, based on your graph, the periods of stability tend to be around 15 to 30,000 years, but the periods of instability seem to be closer to 100,000 years.
Yeah.
Is that correct?
Yeah, sometimes. The latest instability was almost 100,000 years. And then the former instability was about 55,000 years. That's a long time. And then before that, there was an instability period of very short. This is small peak,
like
15,000 years.
15,000 years, yeah.
Yeah. And then before that, it was 60,000 years in instability. And then you have, again, something like 56,000 years, 65,000 years. So it's a little bit goes up and down, but it's a long period. Longer periods of instability than periods of stability.
Yeah.
Yeah, that's wild.
Yeah.
It's crazy to think too that that some of these languages and things that we're trying to decode and understand what these people are thinking could be that far back. Like we're in some ways communicating with people who are possibly hundreds of thousands of years old. That's just awesome to think of.
Yeah.
I do. Before we get to the end of the segment, I know, Marty, you had the slide pulled up of Chichen Itza, was it?
Can I say, guys, can we go back to this last one?
Go ahead.
Because I want to say something, last word on pole 6. Marty. Yeah. Yeah, thanks. There's also pole 6, but because the older the pole, the larger the spot becomes. And pole 6 has such a large area that according to my own method, I cannot define a definite pole.
Yeah.
It's just for 80%. It's too low for my method. 80% is for most people okay, but my positions are going up to 99.99 and so on percent. This oldest pole 6, has some incredible, intriguing structures in them. Nineveh, Sumeria, Sippar, Sumeria, Eridu, Sumeria. And when I think of Nineveh, I think of the Old Testament.
Right.
Yes. Yep.
And there is something in it. I don't know exactly what, but there is something intriguing in this.
So the fact that so many of these sites that align to the oldest pole happen to be in Sumer.
Yeah, definitely.
Eridu is the city of Enki, I think.
That's exactly what I was thinking.
Yeah.
It correlates with
it correlates.
Gilgamesh story and
it correlates so well.
Have you looked at the kings lists? I believe that the Sumerian kings lists have kings that go back
very long time.
What if the kings were actually the poles, man?
Wow. Maybe
the really old ones. This was the pole for 26,000 years. This was the pole.
I don't know. I can leave. Of course, I speculated enough about this in some of my former videos, because I like to speculate as well, because I'm still let's say human being with fantasies and think, how is it? Maybe was this Enki and so on story, the creation of humanity, and it fits very well. Could it be coincidence? It could be a coincidence, but maybe not. Maybe is this story true? And what then?
That's really cool. And what then?
Yeah, what then?
Very cool.
What I know, believe I know the answer, but could you tell us what do you believe is the oldest structure you've dated?
Definitely the oldest is Caral in Peru. That's the oldest, among the oldest structures.
Which is in South America.
Yeah, South America. And also you also see pyramids of Cochasqui. I don't know if I pronounce it correctly. But Caral is definitely very ancient.
Yeah, so during the break, we had talked about Peru and the fact that it was in the southern hemisphere. And you had pointed out that initially you had excluded, or actually I think it was that when you started looking at the older poles, you had to shift the position of Peru. Can you talk about that?
Yeah, exactly. When you look at Peru is located on the southern hemisphere. So you have to say, okay, because they are in Peru, they were oriented to the South Pole. But because, let's say, I leave out everything on the southern hemisphere, leave this out of the data, then I still find these 5 poles. So that I can prove these poles. And then I can inkey these southern structures again, and then look at the distances from these Peru structures to the ancient poles, pole 5 and pole 4. And I find that these structures could have been located on the northern hemisphere originally.
Right, based on the ancient pole, they would have been shifted up and been in the northern hemisphere.
They've been shifted northward quite a bit. Yeah, so they would
quite a bit. Yeah.
Wow.
So that's intriguing.
So you left out southern hemisphere poles? Is that what you're saying? I mean structures just to get this.
Yeah, I left it out and I put them in back again.
Okay.
So
after you come to the you've got these clusters built on northern hemisphere structures. Then you can start entering in the southern hemisphere structures to see if there's a correlation.
Because it's already proven. So you can look at what does this mean for, what could this mean for Peru structures, and then you can start to explain what you're seeing, because they were oriented to all the poles. They could have been located originally on the northern part of our sphere, and then look at let's say the solstice angles in these structures. And
so did that also lead to you wondering if some of the currently northern hemisphere structures on the other side would have been in the southern hemisphere, at pole 5 or 6, and that would change things? No.
This is at Chichen Itza, correct? This graphic?
Chichen Itza, yeah. The pyramid of Kukulkan, El Castillo. And because people know when the solstice moment is in the year, and this is an ancient Maya structure, they start to look at magical events that happen. And when archaeologists found that 2 more ancient pyramids are located inside this one, I started to wonder, perhaps the most recent culture built this as a, let's say, a sort of mythical manifestation of the gods or something like this. And then a snake descends from the stairs, and they all put this down on this structure. But there's no rational explanation for the pyramid to be oriented like this.
Yeah, but the equinox, on the equinox sunrise or whatever, around the equinox, you start to see the shadow descending. Yeah, on the staircase. Yeah,
of course, but because they made this, let's say recently on this pyramid, but the foundation of this structure is pointing to pole 4. And the same. It's for about, I believe, 95% of all the structures on the western part of the sphere are all clockwise oriented like this. And it's intriguing, of course. And so what does it mean? What does it mean when there are 2 other pyramids inside? How old are these? How old are these really?
Yeah.
How old is the foundation? When they started digging around this pyramid, they found much older foundation beneath the soil. And they are all equally oriented. So there emerges a bigger picture of something happening there. So this event,
so there are others.
The equinox or the solstice or whatever is happening here is a sort of, it's okay, people going there, but it's the same as going to Stonehenge and then saying it was a solstice moment of the year. It's doing nothing there, the structure. It's just pointing to an older pole.
Yeah, so I guess what you're saying is this phenomenon that takes place now would not have been happening when they built it oriented to the old pole. Is that what you're saying?
No.
So it's
No. No, it wasn't, let's say, an observatory platform or pyramid to decide for the moments of the year. And it was cardinally oriented originally.
Yeah.
And
interesting.
This is only one pyramid on Chichen Itza, but Chichen Itza has 46 structures. And they are not all, but most of them have a slightly different orientation. And when I examine this orientation pattern, it matches for a very large degree to the pole positions I have found. So this is, again, a returning pattern.
Yeah, so that would be, it is a good question that you could say, well, this one pyramid with this staircase was intentionally aligned to this orientation to give the staircase this shadow on the equinox. But then there's another pyramid that's also aligned to that orientation that doesn't have that happening.
Yeah.
Because its staircase is not built in the same way. So it's like, why is that one turned 22 degrees?
Yeah.
That's cool. Wow.
Yeah.
That's very interesting.
And again, the solstice angles work better when you move it back to the original location when it was at pole 4.
Basically, we have to know this for sure. We have to know what is inside this pyramid.
Yeah,
because the original original builders have perhaps done something else with this.
That's what we want to know about all pyramids.
That's what our job is. We're going to figure out what's inside these damn things.
What's inside? Quicksilver rivers and so on.
Yes.
Yeah.
Well, this has been fascinating. We're definitely probably going to have to get you back on if you agree.
Yeah.
We'll have to get you back on the show. Maybe we'll go further to discuss maybe some mechanism possibilities, all that kind of stuff. I know Marty thinks we didn't cover enough, but Marty likes to have 6 or 7 segment shows.
Marty, listen, we'll get to all that stuff later.
3 hours.
Yeah, we'll get to that stuff later, Marty. That's right, just like Kyle said. So, Maarten, tell people where they can find your stuff and look up your material.
Yeah, it's a good one. MarioBuildreps.com. So Buildreps is a subtraction from building reports.
Okay.
Mario is my pseudonym. I'm writing the book under the pseudonym of Mario. MarioBuildreps.com. And there you can find a lot of content and also YouTube channel. Same, MarioBuildreps.com.
All right.
Now, of course, YouTube.com, but then the Mario Buildreps, Antiquity Reborn. And there's a lot of content. You can sometimes a little bit speculative about Enki and Lil and so on.
Oh, cool! I love that.
Yeah, we love that.
I like to speculate because I like to speculate sometimes too about what does this mean for our ancient history and me as a human being living in this society with money and sometimes oppression and power and non-power, and what does this mean for me and us as human beings? Are we built as slaves?
I was going to say custodians.
Yeah, we got the custodian problem. Yeah.
What does this mean if you are aware that you are built as a easy programmable human being? But we are, of course, we know, guys, that we are more than human beings. We are souls in the making, gods in the making. And
yes.
Yeah. So we basically know what we are, but we are also a human being living in a society where you have to earn money to make a living. You have to listen to the government, have to do vaccination programs because somebody is coughing and you have to put on face masks. We are so easily programmed, and it's okay. It's good because when there's something serious, it's good that people are easily programmed because it can be important, but it can be misused as well. So we have to be aware of this. So Okay. What does this mean for me as a human being? If some gods that came from the sky created the slave species for digging gold for them.
Yeah.
He's getting into my territory.
What does it mean?
Yeah. We
In your lane, buddy.
we definitely went down these rabbit holes. Bro.
We will go down, because what happened with let's say that suddenly a species emerges like that.
Yeah.
Where does it come from?
It's very strange.
It is very strange.
It's explained like a tornado going to a scrapyard and building a fully functional Boeing.
Yeah.
That's right. Yeah. The probabilities. Yeah.
Probability. Yeah.
Yep.
So can science explain this? No, they cannot. So I think there might be some truth in this story. The stories that's carved in stone, and how old can stone be? Very old. We know this. So,
That's right.
Yep. Well, hey, man, I appreciate your attention to detail and the scientific method. And I also appreciate that you feel free to speculate, because that's kind of, it's uncommon to find someone who is well versed in the scientific method also wanting to be free to speculate, or vice versa.
It's necessary to come further, but thank you for the compliment.
That's cool.
Yeah.
I've enjoyed this conversation, and I hope we have another one soon.
Yeah, we'll have to get you back on. And I'll put links in the show notes to your website and to your YouTube channel. Thanks so much for coming on, Maarten.
Okay, brothers.
Yeah.
All right.
And thanks, Marty.
Yeah, thanks for your help, Marty.
Work on your slideshow.
I work on my skills.
Good night, guys.
All right, good night.
Good night.
Okay, bye-bye.